Hey there, Math 112 fans. Are going to finish up this final exam review. Hopefully you found it helpful. Again, I'm worried that people are going to say that's too much stuff, but hopefully you saw that you didn't need to watch it all. I hope you knew a lot of the pieces, but this gave you an opportunity to go a little deeper if you needed to review. So, give me a comment on the discussion board if you found any of this helpful. Something I hope can is something helpful for students, but I tend to get complaints about posting too much stuff. So I don't know that right balance to try to be helpful and not overwhelm people. Something I'm working on. But I hope that you've learned a bit in this course. I hope that you have gained a little bit from what I've given you. In general, I hope you're better at analyzing functions and maybe have learned a few tips to do better in all your classes when it comes to studying. That's my goal. Anyways, multivariable functions. That's the last thing we did. We talked about if we are analyzing a function of two variables, we can compute these things we call partial derivatives. The idea of a partial derivative is we keep one variable constant as if it's not changing at all, as if it's a number, and then taking the derivative. What we mean by that, if I take some value like 3, 4, we think of it as assume I've sold 3 of one item and 4 of the other item, and then I only study what happens if you alter the first item. So we talked about this in terms of definition. I'm just going to mention this briefly because I spotted it in quite a few old finals. And the idea is what happens if we increase x slightly, what happens to the slope? And so then we said, well, it should be the smaller this number is, the closer it should get to the slope in what we call the x direction. How does that differ from the other one? Well, the other one looks like this. If you keep everything the same but only change y, how does the slope change? And that's this. Now, the smaller it is, the closer they are. That's that slope of the tangent idea from the beginning of the term. But usually in business, we just think of it as 1. If we sell one more item, what will happen? And that was our interpretation piece. So let's just make up some numbers. Let's say this is 10 and this is 8. I know I've just ran into my thing here. I'm going to make a few adjustments. Put this down here for a moment. If we were selling 2 items and the first one represents, I think I always use like hats, and the second one is scarves, then we would think of this, the first one, as dollars per hat, and we think of the second one as dollars per scarf. And we would interpret it as if we sell one more, if this is profit, let's say, if we sell one more scarf, we'll get about $8 in profit. If we sell one more hat, we'll get about $10 in profit. That's what that was. Now, the big thing we learned was if both are 0, that's going to correspond to what we call a critical point. And we didn't go into tons of detail about all those pieces. If you do want to, sort of lock in, and hopefully you've been doing this all term, my goal was if you got stuck on the homework, you would watch lecture, go to the lab. But in addition, I had these supplements. I think because of the way people interact with courses now, they don't go look at my review sheets as much. So I have to think about that. And it seems a video is more desirable. But if you were struggling, you could have gone through this. This basically says what I just said. It has several examples. Where I do partial derivatives, a whole bunch of examples. So I made this to help people, but I realize now it's review sheets have suddenly become obsolete because people like to use videos and other things instead. But if you want a deeper understanding, I'm trying to think of how I could sell this and convince people to look at this more. So this sort of talks through it. It finds some critical points. So if you really were struggling, you could go through that sheet, read it, 5 pages of reading, and you would have mastered it. Well, I think you would have, but still need some practice. So that's just an idea for the future. Maybe you have some thoughts about how I could integrate that if I taught this course again so that people would use those as they were doing the homework. Anyways, that's a side topic. So let's finish this up by looking at a collection of old final questions that relate to this. Okay, and let me have I found it helpful to have the exam archive at the ready, just in case there's a numerical value we need to check. Okay, we'll put that in the corner and zoom back out when we need it. So here we go. Your company produces and sells gloves and hat. I think this is the spring 23 final exam. So gloves and hats. Everything's in hundreds. The only thing that really affects is how we interpret our final numbers. So we'll leave that for the moment. The profit is this. Compute the partial derivatives. So we've done this so many times now in the last week that maybe I won't do a full review. But in terms of, maybe just for the first one, you're trying to say, if x is my only variable here, and everything else is a constant, what are the derivatives? And some of the things I've been noticing is people just have forgotten that the derivative of x is 1. The derivative of x squared is 2x. That's all you need to do this. This is going to become a 1. This is going to become a 1. This is going to become a 2x. Those are the only derivative skills you need here. But you do need to remember other things. Like if there are no variables, then it's a constant. The derivative of these two things are 0 with respect to x. Everything else is what we call a coefficient. So your final answer will have an 8. I like to say the coefficients come along for the ride. So let's do that. The 8 comes along plus the x became a 1. So that's where it didn't vanish. The x became 1 here, and this is going to be 4y. That always bothers students that there's a y, but the y was a coefficient. And lastly, it's going to be 10x. We've done that a lot. So you need to be ready because you're going to have trouble with this question if you can't do that. Okay, so then we're going to switch gears and we're going to look at y. The derivative of y squared is 2y. And this is 1. And now we're treating everything else as a constant. There's only 2 terms that have y's in them. So what do we get? This becomes 4x minus 2y. And if that's still bugging you, go check that out. Check out this review and do all the examples in there. And if that's still bugging you, go to my old lecture notes and do a whole bunch here. There's more and more, just tons of practice from our lectures. Okay, we need to master that piece. So then we have one of these applied questions that says, all right, what's going on? Oh, they're adding slightly to x. So this is one of these 3 plus a small amount, comma 4 minus, this is a slope. And what is it looking at? So this goes back to the thing I said at the beginning. What are we talking about? We're talking about x. X is what's changing. How does a slight change affect our value when we're at 3, 4? So this is asking you to just plug in a 3, 4 into the partial with respect to x. So x is 3, y is 4. So it's going to be 8 plus 16 minus 30, which is negative 16. Hopefully I did my arithmetic right. Let's grab this exam. I'll make this a little bigger. Sorry for the sound effects. I've been doing a few hours of videos and getting a loopy. Oh, it's negative 6? Is that right? It is negative 6. I told you I was getting loopy. Shouldn't record for 3 hours in a row. But I want to get these all out. I know students are wanting to get this. So I'm going to put this here. Okay. I mentioned in class that I won't ask this on the last page of the test because when you plug this question that says plug in x equals 1 and consider what you get, it no longer is a multivariable problem. And I'll show you what I mean. So if you plug in a 1 for x, I'm just going to do it. You get 8 plus 4y minus 5 minus y squared minus 4. And that means you're going to get, let's see, negative 1 plus 4y minus y squared. Now, at this moment, it stops being a multivariable problem, which is part of the goal. This is actually really is a review question that has to do with analyzing. And I definitely could ask you this. I just promised you that if I asked you such a question, it would be earlier on the exam. But let's just do a quick review. How do you do a global max and min on an interval. You should know what to do. You know you're going to plug in 0. Those are the endpoints. You're going to plug in 3. You're going to get the output value. And then in addition, you're going to take the derivative and find when it's equal to 0. That gives you y equals 2, which means you also have to plug in 2 and get the z value. So that was just a one variable problem. And I used to always just mix these in with the multivariable problems. But I promised this term that I was going to save that on a different page, so I'm going to follow my word. All right. Finally, you have to find the critical point. So let's play that game. Let's grab our partial derivatives and see what we get. And we're going to set them both equal to 0. And just a chance to combine and solve. So we want to know first when this is 0, and second when this is 0. Pick whichever one looks easier to simplify. To me, the second one looks easier to simplify, and solve for one of the variables. Okay, I'm going to do y equals 2x. I divided both sides by 2. And now we substitute. So now we're going to take equation 2, substitute it into equation 1, and that should lead to a situation where we only have one variable. And that's going to be 2x. So we get 8 plus 8x minus 10x is 0. So we get 8 minus 2x is 0. We get x is 4. The moment you have x is 4, you can plug it back in everywhere, and you should get the same y. In this case, you just get y is 8. That's our critical point. And you can check your work. We talked about that. If you want the corresponding profit, you plug it into profit. There you go. All right. So let's look at another one. Okay, so here we have another partial. I think this is from winter 2019. Let's grab this. Winter 2019 final. Probably one of the last 2 pages. No, not winter 2019. Somehow I have the wrong one here. Winter 2018? Maybe? Sorry for the scrolling. You're probably getting sick here. Okay, this is winter 2018. So now we're going to do the partial with respect to x. If you're a calculus student, you want to rewrite this, not because of the first term, and not because of the second term, but because of the third term. I would really like to write x to the negative 3. That leads to easier calculus. Let's shrink this once again. Sorry for all the shrinking and growing here. And so now we're going to do the partial with respect to x. So we're going to get 14. So the only 2 x's I see here are this one and that one. Everything else is a constant. So the derivative of this is 0. That bothers people a little bit, but there are no x's in that term. And so you're going to get negative 6 y to the 4th, x to the negative 4. If you're wondering where the negative 6 was, I brought the negative 3 down. And now we're going to take the derivative with respect to y. There's only 2 y's in this problem, this one and this one. The derivative of log of y is 1 over y. So I'm going to write negative 12 over y. And I'm going to write plus 8 y to the 3rd, x to the negative 3. What is this talking about? It says take the partial with respect to x and plug in 2, 1. So you're going to plug in a 2 here, a 1 here, done. What is this talking about? It says if you replace y with 1, what do you get? Well, if you replace y with 1, you get, I'm just going to plug it in, log of 1 is 0. So you get 14x plus 2 over x cubed. The moment I write that, and I'm going to scroll up here a little bit so you can see it, it's now a one variable problem. It says, is it increasing or decreasing at 3? Well, I need its derivative. Now, you could go back and think about what is the equivalent partial derivative, or you could just work from here. The first derivative is 14 minus 6x to the negative 4. What happens when you plug in 3? Is it positive or negative? And then it asks the second derivative. What happens when you plug in 3? Is it positive or negative? So that's actually not a multivariable problem. Let's grab this and take a look. This is one of the last problems. So there's that function. I took the derivative. I plugged in 3, it was positive, increasing. I took the second derivative, I plugged in 3, it was positive, concave up. So again, I won't ask that on the last page of the question because I told you if I was going to ask about increasing or decreasing or concavity, I would do it on an earlier page on the test, and I'll keep my word there. Okay, then we had this question, which said, find the critical point of the profit. So first step is you have to write down the profit function, which is revenue minus cost. And then distribute. And so this is just kind of messy initially. To me, it's worthwhile to simplify a little more. It's going to be plus 16x. So I just combined these two. I plus 16. I don't know why I wrote them later. It doesn't matter. Okay, so there is this added challenge in this question, which was I had to first write profit before I could find its critical points. Now, once you've done that, the rest becomes fairly standard. Partial with respect to x, negative 4x plus 2y plus 16. At this point, I'm not going to keep stopping and talking about how to do our partial derivatives. Hopefully, we're getting better with this. Set this equal to 0. Now, here's an interesting case where you can, I wouldn't say not bend my rules, but your goal is to combine conditions. And so just a small comment, since I'm making a supplemental video and this isn't like in class. I mentioned in class because I found over the years that students want a precise method to follow because I find a lot of people make mistakes on this. And so the method I have suggested that always works is to pick one equation, it doesn't matter which one, and solve for one variable. And so if you do that here, here's what happens. So I took the first equation, I'm going to go till I get y by itself, 4x minus 16, and I divide by 2. And this works very well. It's definitely the most general method. You substitute in, you solve, and we'll be done in a few steps. So this is not bad at all. I just wanted to comment that when you have two things that line up perfectly, like this 2x and minus 2x, there's another clever technique. And the clever technique is if you have two things that are both equal to different things and you add them side by side, you can say this. If you add two equal things to two equal things, you do get equal things. It's not that profound. Why would that be helpful here? Well, the reason it's helpful here is because the 2y and the negative 2y cancel. So if we add things side by side, you get 0 plus 0 is 0. You get 32. You get 0. The reason I don't mention this in class is this only works well if you can get things to line up perfectly. This question happens to line up perfectly. And so you can get to 16 for x faster, slightly. You still then have to plug in 16 for both x's and solve for y. And in doing so, you have to still do a little more solving. So it's not significantly faster. It's very slightly faster. Okay, so you can see in my solution, I actually did the method I'm talking about here. All right, let's keep going. What's this one about from another old exam? Partial with respect to x, negative 2x plus 6 plus 2y. Partial with respect to y, negative 6y plus 2 plus 2x. Find the critical point, so we want to know when both these things are equal to 0. This one and this one. So let's simplify one of them. How about the first one? This is one you also could add, incidentally, but we'll move everything over. We'll divide. Y is equal to x minus 3. Divided everything by 2. Now we're going to substitute it in right here. And let's see what we get. So we get negative 6, x minus 3, plus 2 plus 2x is 0. So we get negative 6x plus 18 plus 2 plus 2x is 0. So we get 20 minus 4x is 0. X is going to be 5 after a little bit more work. So that gives us the critical point. And now we plug that in here. And we get y is 2. So the only critical point is 5, 2. I don't know why I have this in bold all. I remember that confusing students. I think that was an accident on my end to include that. There's nothing wrong with what I wrote, but it made people think there were more. This is this old exam, I think. Or maybe it was this one. This old exam. No, you can't see that. It's tiny. I'm just doing a quick check to see if what we got was reasonable. Not this exam. This exam. Sorry, I should have this at the ready. Maybe this is my oldest exam. But I think I've given you enough to think about. I might stop here in a second. Goodness, I don't know which exam this was. It's a bonus exam. Same thing there. Partial derivatives. Okay, I think that's enough to give you the idea. You can ask me more questions during our Zoom session on Monday if you wish. Hope that's helping you. All right.